Welcome back to part two of the causes of the seasons. We have crossed off a couple of the first possible reasons for summer here in Central Oregon. The sun does not give off more heat energy in June. It's an 11-year cycle. The Earth is not closer to the sun in June. It's actually farther from the sun in June, so that can't cause the seasons. So the next one is to look at the length of the days. And we know that days are definitely longer during June here. And in fact, here in Sisters, what we're going to do is actually take a look at three different locations. One of them, the state of Alaska. We chose a city in the central part of Alaska, Fairbanks. We've also got Sisters right here in Central Oregon. And then Mexico City, right in the middle of Mexico there. We're going to take a look at these three different locations and see how the length of the day changes based on the seasons. And so the assignment we did was to graph the hours of daylight in these different locations. And if you haven't done that yet, I would ask you to please take a moment to graph those, get the assignment offline, and graph those numbers. And essentially, as you graph those, here's what that looks like. Here's the line for Sisters. In Sisters, Oregon, essentially you can look and say, oh, all right, in June, for instance, June we have approximately almost 16 hours of daylight, 15-something hours of daylight, which means that the rest of the 24-hour day in June, every day is 24 hours long, if you've got, say, 16 hours of daylight, you're going to have about 8 hours of nighttime. Okay? Same thing if you look anywhere along this graph. In September, looks like about 12 hours of daylight, which means you're going to have about 12 hours of darkness. And in December, somewhere around a little over 8 hours of daylight, which means the other 16 hours or so of the day are going to be darkness. So essentially everything underneath the line of the graph is daylight and everything above it is nighttime. Now when you graph these three locations, you find that the day length changes quite a bit depending on your location. And things that you might notice about this graph is that, wow, Alaska changes a tremendous amount over the course of the year. June has incredibly long days, 22-hour long days, and only 2 hours of darkness. And in December, you've got days that are only about 4 hours long and about 20 hours of darkness. So a massive difference between summer and winter. In Sisters, moderate difference. And in Mexico, hardly any difference at all between winter and summer. Other things you might notice is that the longest day of the year in any of these three locations happens right about the same time, somewhere near the end of June. And the shortest day of the year happens right about the same time as well, right somewhere near the end of December. So wherever you are, those longest day of the year and the shortest day of the year, it's the same day, however, it's just a different length. And then one other peculiar feature about this graph is that they all seem to intersect. The three lines here intersect right at that point, somewhere in March and then somewhere in September. And what this tells us is that on those 2 days, one in March and one in September, you've got exactly 12 hours of daylight. And actually, we have a name for that day right there. It's called the spring equinox. Happens right around March 21st. And equinox means equal night, which means you have the equal amount of night and day. Happens again in the fall, right around September 21st or so. And same thing, 12 hours of daylight, 12 hours of darkness, no matter where you are on Earth. That's the truth. That's the case. The summer solstice is the longest day of the year. Happens on right around June 21st. And the winter solstice is the name that we give to the shortest day of the year. Happens right around December 21st or so. Now, all these are 21st or so because our calendar is a little bit goofy, 31 days in some months, 30 in others, 28 in one month. And every so often we have a leap year, which kind of shifts everything by a day or so. And so it's usually right around the 21st of each of these 3 months, or each of these 4 different months, but not always exactly on. Now notice that there's 3 months between the spring equinox and the summer solstice, 3 months until the fall equinox, 3 months then until the winter solstice, and 3 months until the next spring equinox. All these are located exactly 3 months apart in the calendar. And the reason for that is that the Earth is moving at a very regular pace around the sun. Okay, so when we look at that graph, we see, wow, Alaska has a massive change in day length. And when we think Alaska, we think about the temperature. The winter, it's bitter cold up there. What about the summer? Is Alaska cold in the summer? Actually, it's not. The central part of Alaska really gets pretty darn hot in the summer. They've had temperatures in the 90s. And in fact, if you look at the average monthly high temperatures, the average anyway in the summer months in Alaska is in the low 70s. And in the winter, January for instance, their average high temperature of the day is right around 0 degrees Fahrenheit. Ow, that's cold. So we have a massive range here. If you look at this, a 70-degree Fahrenheit range between winter and summer. A huge difference between your winter wardrobe and your summer wardrobe, I would say. Massive range, and that seems like it lines up pretty well with the huge range in day lengths as well that we have on your graph. So let's take a look at the average monthly climate here. The high temperature in Sisters in the summer, low 80s is the average high. In the winter, right around 40 is the average high. Obviously, it gets colder sometimes, it gets warmer sometimes, but the average high over the years is right around 40. So we have a range here, more moderate, kind of a moderate range of about 40 degrees Fahrenheit. And what about Mexico? Mexico, you're looking at hot, so you're up in the mid-80s in the summertime for an average high, and in the winter, still pretty hot in the low 70s. The range here is a very small range, only about 13 degrees Fahrenheit. Not a very big change in your wardrobe if you were to look in your closet, pretty much shorts and flip-flops. All right, so do these match up quite well with the ranges of the day length? Does day length match up with the climate that we experience in each of those summers? So here we go, or summers and winters, I should say. The range in Alaska is huge for day length, just like it is for the temperature range. In Sisters, the range is kind of moderate, just like it is for the temperature range. And in Mexico, the range is very small for day length, just like it is for the temperature difference. So they seem to be correlated quite well. Day length seems to correlate quite well with high temperatures. But just because things have high correlation does not mean that one causes the other. For instance, shoe size correlates pretty well with math ability. Right? If you were to make a graph of shoe size and how it affects your math score, you would find that it's actually a pretty strong positive correlation here. But just because one thing correlates with another doesn't mean it causes it. Does the size of your shoe cause you to be good at math? No, in this case, if we think carefully about it, if you have a tiny shoe size, you're probably a baby, in which case your math scores are going to be pretty low because you haven't learned much yet. The idea here is that these are correlated, but one doesn't cause the other. So we can't necessarily jump to the conclusion that just because they're correlated means that one causes the other. We need to try and connect them using some science concepts. If we can actually explain the correlation in terms of cause and effect, then it'll make more sense. Then we can actually say that it causes it. So, can we actually explain how the length of the day could affect the average temperature? Certainly we can, and it's pretty easy really. Light energy from the sun hits the earth and warms it up. So light energy turns into thermal energy when it's back into the earth. And if you have light energy hitting the earth for a longer period of time, a longer day, what you end up with then is warmer temperatures. So in this case, explaining the correlation here gives you a pretty simple explanation of the causation. In other words, length of the day does cause average temperature. We can see it in the data, and we can explain it using science concepts. Essentially what we're saying is, cook a piece of steak for a longer period of time, it's going to be hotter. Makes sense. But wait. It does seem to cause high temperatures. The day length does affect the different seasonal temperatures or seasonal climate. But can it explain this scene in December off the coast of Argentina? Santa Claus wearing shorts in December. Yes, it can. Let's take a look. So far we've looked at Alaska, Sisters, and Mexico. Let's move south of the equator down here to Argentina. So I chose a city in the middle of Argentina here, and we went ahead and added some data to our graph. So if you haven't done this yet, go ahead and pause the video and add this data to your graph, and let's find out what the day length looks like in Argentina, and we'll compare it to the temperatures there. Okay, so here's what we see. The line for Argentina passes through those same 2 points, but it's inverted. It's low where all these other ones were high, and it's high where all the other ones were low. It's the opposite of what you'd expect. In June, you have the shortest days of the year, and in December, you have the longest days of the year in Argentina. So what does that mean? Well, let's see. Does it correlate with the temperatures there? It actually does pretty well. A moderate range here. And in June and July in Argentina, that is their coldest season. That's their winter. And in January, for instance, that's their warmest temperature. So what they have is actually summer for them is kind of in January, February, and winter happens during June and July. That's their coldest time. Crazy. Fall then happens for Argentinians between summer and winter. So fall south of the equator is in March, April. That's right, they're losing leaves off their trees in April. Crazy. And in spring, they are out trick-or-treating for Halloween. That's right, their Halloween colors might be more of a pastel as opposed to black and orange. Spring happens when we have fall. So, actually, before we do that, when does Santa come? Santa shows up at the end of December, and we're getting into the highest temperatures of the year. That's their summer. So Santa shows up in summer wearing shorts. When Santa delivers presents to Argentina or Australia or South Africa, wherever south of the equator, definitely comes wearing shorts. So how does that look compared to sisters? Sisters in Argentina are almost exact opposites. Not exactly, but pretty close. So when we have winter in February, for instance, January and February, they're having summer. And when we're having summer in June, July, and August, they are in the midst of their winter. So if you travel to the other side of the equator, make sure you pack accordingly because the seasons are going to be opposite of ours. So day length, again, correlates quite well, and we can explain that causation using cause and effect. Day length does cause the seasons. So where are we in our possible reasons for summer? Not that one, not that one, but the days are definitely longer during June here in the Northern Hemisphere. We are cooking longer, and that is definitely one of the causes of the seasons. Stay tuned for part 3 coming up next.